Iona Static Band is a new wearable ESD monitor that measures the user's body voltage without any tethers or connections to ground. This may seem impossible, but there is some solid physics and engineering behind it, as we'll explain here. First though, let us show you the accuracy of the static band's measurements.
Here is a 3M surface voltmeter, what we consider to be the gold standard for body voltage measurement. We're showing a live plot of my voltage while I perform the ESD shuffle with non-compliant footwear and flooring. When I turn on the static band, the same voltage data is being displayed to high accuracy. And more importantly, when I release the 3M probe, I keep collecting the same data while being able to move around the facility.
How does Iona's device actually measure the human body voltage? Well, all conductive objects have some capacitance. For simple shapes like a sphere, we can calculate it. For more complex shapes like a human body, it's a little harder, but they all have a basic intrinsic capacitance. And when that capacitor acquires some charge, then the voltage of the object goes up according to a well-known equation, V equals charge over capacitance. Now, we can't measure that voltage directly. In order to do so, we'd have to have some kind of wires to a voltmeter. What we can measure, however, is the electric field produced from the skin of the body. And Iona has developed the world's smallest and most accurate electric field sensor, what we call an electric field mill, that measures that electric field. Now, it's well known in physics that the electric field is proportional to the charge density, the amount of charge that's on the skin of the body below that electric field sensor. From the charge density, we can make an estimate at the amount of charge on the whole body. We can just multiply or extrapolate that charge density to the charge on the entire body. Once we know that, we have the charge, we have the capacitance, and we can calculate the voltage. So our sequence of measurement goes from electric field to charge density to total charge to voltage. And that is how Iona is able to make a body voltage measurement without any wires.
Since the static band samples the electric field at 1200 times a second, it's able to identify rapid drops in body charge and voltage that can only result from a transfer of charge to another object. For example, if I build up some charge on the carpet and then step on the grounded floor, you could see an ESD event happen. I can repeat the same thing by touching a ground point on the ESD control meter. This ESD event detection is fundamentally different from other ESD event counters on the market that rely on electromagnetic signatures of discharge events. It really is an unprecedented tool for identifying human body model ESD events in protected areas. There are a few scenarios in which the relationship between E-field and body voltage breaks down. For example, if I'm naturally charged and I stand next to a grounded workstation or wall, the charge distribution on my body will be asymmetric and the voltage measurement from the static band will be slightly higher or lower than my actual voltage. However, the polarity is always correct and zero charge means zero voltage. Second, if I stand next to a charged insulator, such as this acrylic banner, the charged panel will induce a charge in my body even if I am grounded, and the static band will detect this. Just remember that a non-zero voltage measurement from the static band always indicates the presence of charge on the user, which should be considered an ESD concern.
We hope that this explanation of the physics behind the static band has been helpful, and that our new product can be a vital part of your organization's ESD mitigation practices.